So we've looked at what a radian is, how it's different from a degree but also kind of the same in some ways, how it's defined in relation to the circle rather than just kind of arbitrarily splitting our amount of turning up into some number. So it's kind of, there's a more mathematical feel to it, but at the moment, is it much more useful? Well, let's have a look at one of the first and most straightforward applications of this new angle measure, radians, and that is calculating the length of an arc. So say I've got a circle with a radius of 5 centimeters and my arc length and my angle is 130, and my question is, how long is that line? Okay, it's a straightforward question. So the arc length is, well, it's a fraction of the perimeter. So it's in this case 130 out of 360. This is the fraction of the circle we have, multiplied by the circumference, which is 2 pi r. Well, we can tidy that up a little bit. So 130 over 360, I can cancel a 10 out. And then r is 5, so this is just 10 pi. At this point, I'm just going to grab my calculator and I'm going to ask the calculator. So 13 out of 36 times by 10 pi. Oops, I've missed my times sign, haven't I? Let me try that again. Times by 10 pi. And we get this thing here. It's 65 over 18 pi. But I have to kind of work quite hard at memorizing this, and I've got an awkward sort of answer, but you know what, that's not the end of the world. It's quite doable. However, this is in degrees, and we have been playing around in radians, so let's have a new circle. It can still have a radius of 5, but this time let's give it 2 pi radians. Not 2 pi radians, sorry, 2 radians as the angle. Okay, and I'm going to ask the same question. It's not miles off the same angle, so we're not going to get miles off the same answer, but what we're going to do is this. We're going to do the same thing. So the arc is a fraction of the whole circle. So 2 is my angle. What's the whole circle? Well, a full term we already established is 2 pi radians. And then I'm still going to multiply that by the area of the circumference of the circle. That doesn't change based on the unit we measure angles in. That's still going to be 2 pi r, because it's still a whole circle. Oh, but look, now I am dividing by 2 pi and multiplying by 2 pi. They just cancel out. So actually my arc length is just 2r, or 10. And that's it, I'm done. And in fact, we can generalize both of these. So if instead of having my angle of 130, I just had theta, my rule for the arc length in degrees is theta out of 360 multiplied by 2 pi r. And I can't do any better than that. Nothing really tidies up here. I mean, I suppose I could cancel the 2 and the 360 out and have theta over 180, but that doesn't massively improve things. I can't beat that, really. I need to know the angle and the radius, and I need to plug it into this formula which involves pi. Whereas down here, my angle is still theta, but now it's out of 2 pi multiplied by 2 pi r. The 2 pi cancels every single time. It doesn't matter what your angle is now. So actually, the arc length is the angle multiplied by the radius, and that's it. This right here is the formula for the arc length of a circle when you're working in radians. That is a tiny formula, an incredibly simple formula. It's far easier to deal with than having to work out the angle, the circumference and the fraction and deal with all of that. So you'll see the first little section of the textbook here. It just says to find the arc length. of a sector of a circle, we use the formula L equals r theta. When they write r theta instead of theta r, it doesn't really matter which way around. R is the radius and theta is the angle. And that's it. That is all that you need to know to find the arc length if we are in radians.